Alright, let's look at an example of a surface integral, and this one is rate of fluid flow. Alright, so let's say rho is given to be the density of a fluid. So you have some sort of fluid, water or whatever, or syrup. Density is given by rho, and it's flowing, and its flow is described by this vector field v. So this is a velocity vector field of the flow. Right, so the unit of example unit of the density would be mass over unit volume, so like a kilogram per cubic meters. Right, the velocity vector field, so since it's a velocity, so let's say this is going to be meter per second or something like that. All right, so what happens is if you want to know the fluid flow through a certain surface, so we want to actually find a rate of fluid flow through a surface S, right? As usual, S is too big, so I'm going to look at the small region delta S. So we have this delta S right here, right? How much water or fluid going through that little piece of surface, right? So we're going to look at, let's see, I'm going to just look at the delta S. Let's say I'm going to pretend that this is a nice and flat region, right? So this is the delta S, right? And the fluid is going in the direction of the vector field here. So let's put a vector field. So vector field, let's say going, let's say in this direction. So let's say this is vector V. Right, so if you think of this like a water or some sort of fluid, and it coming out this way, and you want to know the amount of fluid coming through that hole, right? So it comes down to finding the volume of this parallelepiped, right? And to do that, all we have to do is we can just simply find the height of this, right? So go straight up. And this can be found simply take vector v and look at the normal component. Normal vector is perpendicular to the surface. Normal component of that gives you the height. So the whole volume can be found, we're going to say delta V is going to be, right, surface area is delta S times height. So you can find it by V dot N, normal vector, and multiply by delta S, right? But if you want the mass, you just have to multiply the volume by its density. So you have a rho times delta V is going to give you a rho V dotted with the unit normal vector delta S, right? So this will be the rate of flow. Maybe I should write it. This is a rate of flow through this little piece of surface delta S, right? Then if you want to find the rate of flow through the entire surface S, you basically have to add them up using integral, right? So this is going to be, so if you're looking for the rate of fluid flow through the entire surface S, all you have to do is do the surface integral, so it's a double integral over the surface S, right? Then you would have to density times velocity function, velocity vector, and dot it with the unit normal vector of the surface, and delta S becomes ds. Right? So you can see that this is a surface integral can be used to find the rate of fluid flow through the entire surface S. Right? That's it. I hope that this was clear.